are picking up where we left off in, what are we at, 11.3, right? And yesterday we talked a lot about mean, standard deviation, and we talked about that 5-number summary, right? That helped us create a box and whisker plot. We're still going to be working with some of that information, but today's focus is going to be more on the shape of the data, okay? Does the shape of the data have more of a symmetric shape? And when I'm talking shape of the data, kind of like the bell curve, if you're familiar with the bell curve, where as you go out on the ends, there's less and less and less, but most of the data is in the middle. So is it like a symmetric curve like that, or is it a skewed curve, where it's, I don't know, a lopsided bell curve, so to speak? So, to compare the different types of distributions, we're going to look at the shape, the center, and the spread of the distributions. Now, we talked about standard deviation yesterday, but standard deviation, range, and interquartile range are 3 ways we measure the spread of the data. So yesterday, if I go back to the first box and whisker plot, that box and whisker plot is kind of a way of showing us the spread of the data because it's kind of lopsided, isn't it? And so by it being lopsided, having one longer whisker, the majority of the data is right here, and this is going to be the longer tail that kind of goes off to the side, okay? So that's a way to show us the spread of the data. But standard deviation, range, interquartile range, I'll describe those. Range, do you remember what range is? Go back in your math career. Range is biggest value minus smallest value, max minus min, however you want to put it. Okay. Interquartile range. Interquartile range is going to be the range between the quartiles. So upper quartile minus lower quartile, or in other words, third quartile minus first quartile. And then we talked about standard deviation yesterday. Now, skewed distribution. One with a shape that is stretched out either in the positive or negative direction. As opposed to a symmetrical distribution, has a shape that, when reflected across the mean, the display is roughly the same. So if you look here in the middle, this is an example of a normal distribution or symmetric distribution. Both ways to say the same thing. But the idea is that you have the majority of the information all together in the middle there. In a symmetric or normal distribution, your mean, median, and mode are all about the same values. Whereas in a skewed option, and we have a skewed left option and a skewed right option, in other words, whichever way your curve is lopsided there. But in a skewed left, what's happening is we've got more of this higher information here, okay? Higher numbers, that is, and that makes my mean lower than my median here, okay? So in other words, they're not the same. It kind of, what do I want to say, contradicts where the middle is, okay? Is it the mean? Is it the median? It depends on the situation. Whereas in a normal one, they're the same. Skewed right, my mean is going to be bigger than my median. And again, that's because those smaller numbers pull, or those bigger numbers there pull my mean away from where the middle should be, because middle should be where the bulk of the data is, okay? So those are some things we're going to look at. You've got some definitions here that I just mentioned. In symmetric, mean, median, mode are all about the same. And in that case, when you're asked what measure of center and spread do we want to use, if mean, median, mode are all about the same, we're going to use the mean and the standard deviation to describe the center and spread. If, however, you have a skewed distribution where the mean is more affected than the median, we're going to use the median and the interquartile range to describe the center and spread. So that the key here is going to be deciding which is it? Is it symmetric or skewed? And then which values do I use because of that? Mean and standard deviation, or median and interquartile range? So an example to go along with this. What measures of center and spread would you use for the following data set? In other words, should I use mean or median? And should I use standard deviation or interquartile range? In order to figure that out, we need to know, is this a symmetric distribution or a skewed distribution? You might be able to just look at your data and be able to tell. Okay? You might be able to look at it and be able to tell if it's skewed one way or the other, or if it's spread out pretty nicely across the board. However, you might need a little help in telling for sure. One option the book suggested is making a histogram. You guys even know what a histogram is? Do you remember? No? Remember a histogram? Histogram is kind of like a bar graph, except in a histogram, all your bars touch, and they each represent an interval of numbers. Oh gosh, that was bad. Not what I meant to do there. Okay, so like this is the idea of a histogram. Each bar represents some range of numbers. And the idea is you can use it to tell, is it symmetric like this, or is it skewed one way or the other? Now, here's the deal. I also played around with this some last night, and I kind of came up with the conclusion, if you don't pick just the right intervals in your histogram, it doesn't really help you. And so I kind of decided that's not the way I'm going to go with it. I'm going to go with the suggestion of, it talks about the mean, median, mode are all about the same or all different. I suggest we find our mean, median, mode before we decide how to answer this question. Okay, so let's give me my suggestion. So we're going to find the mean of this group of numbers. We're going to find the median. And we're going to find the mode. And then we'll decide what we think we need to do. So I hear the calculators popping open, right? Let me know what all the numbers add up to. What are they all adding up to, and what am I dividing by? I agree. And we're going to take 399 and divide by 15. What is 399 divided by 15? Is that 26.6 repeating? No, just 26.6. Okay. I think the 0.6 repeat is somewhere else then. Okay, median. What's my median look like? Yeah. When you count in, there's 15 numbers, so you're counting in 7 each way, and it's the 8th number from either direction. And that median is going to be 29. Mode. We haven't talked about mode, I don't think. Why 33? Yeah. One that repeats the most, the one that occurs the most often. That's back in your brain somewhere, isn't it? I saw several people like, oh yeah, I remember that. Okay. So 33 is my mode. Do you need to write a note to yourself that's the number that occurs most often? Maybe, right? Okay. With that in mind, so as you look at the mean, median, and mode, are those values all about the same? Or do they vary? They vary. They're not the same enough to say they're the same. Okay, and specifically when we start talking about that, we've got to look at mean and median. And what, 3? I guess they're only a little over 2 off, but still, this is kind of a small group of numbers, and so they do vary. Now, because my mean, median, mode are not all in the same spot, is this going to be symmetric or skewed? This is going to be one of my skewed options, isn't it? Okay, the data is going to be skewed. Specifically, notice my mean is less than my median. If my mean is less than my median, which example does this fit? This is skewed left. Okay, so I'm going to write myself a note here that the data is skewed left. And I know it's skewed because the mean, median, and mode all vary. Okay? Okay. Now, what was the actual question here? What measures of center and spread would you use? Well, what do we know here? This data is skewed, yes? Because mean, median, mode all varied. Because the data is skewed, what did we say? In a skewed distribution, the mean is more affected than the median, and so we're going to use the median and interquartile range. And we need to find those. Okay. So mean, median, mode are all different. Means my data is skewed. What is the median? We already found that earlier, didn't we? 29. Remember another way I mentioned that was to, you can use the X bar. This is a friendly little reminder there. Okay. What are you thinking about interquartile range? Well, in order to use interquartile range, what do we have to find? Yeah, we can't do this if we don't know our quartiles, do we? Now, I didn't find quartiles earlier because did I have to know them at the time? No. But in order to find interquartile range, I have to know them. So, with that in mind, okay, guys, remember this from yesterday? We already have the median. Do not include your median when you're looking for quartiles. So that means I'm going to use the numbers from that 29 right there to 10. What is the quartile, or what's the middle of that group of numbers? 21. So that is going to be my first quartile. On the other side, so now above 29, we're using the 30 to 37. What's my upper quartile? 33. I feel like saying pick one, right? So in order to do interquartile range, it's the third quartile minus the first quartile. Can you handle my shorthand of Q3 minus Q1? That's my way of saying quartile 3, the third quartile minus the first quartile. So we're going to be doing what? 33 minus 21, which is 12. Okay. Questions there? Okay. Ready to try the next one? Okay. Okay, what you need here. Oh, and I forgot to ask, by the way, when we talk about this data being skewed left, Does it make sense now that you look at the numbers? Because over here on the right, you have a whole bunch of 30s clustered together, yes? A whole bunch of numbers all in the same area. Whereas over here, I have 20s, I have teens, they're more spread out. And so that's going to lead us to the idea of a skewed left look. Okay? So, okay. Well, example A down here. What are the better measures of center and spread? My suggestion is find mean, median, mode. I should have looked and see how Savas took you guys through this. I don't think I looked. They could say something like draw a histogram. I don't know. Okay. Any luck on mean? What are they adding to? What are you dividing by? What are you getting? Okay. 696. Dividing by 12. And we get 58. Okay. What about median? 58. One of them there, right? Did you already check? You already realized your numbers are in order, yes? So if there's 12 of them, I'm going to count in 6. And we end up between the two 58s, yes? So in between a 58 and a 58 is 58. What about mode? So remember, you're looking for the number that repeats most often. In this case, we have 2 numbers that repeat most often. We have 2 numbers that both repeat, 3 times? And so my mode, I have 2 of them. My modes are 57 and 59. Okay. So what are your thoughts about this mean, median, mode? Are they all pretty much the same? And here's the key right there, guys. It's not even so much about the mode. It's more about the mean and the median. I could probably teach this actually without us finding mode. I don't know. We'll find out. Maybe it'll be something they'll matter on. But my mean and median are the same. Okay, that means it's going to be a normal distribution or symmetric. Okay? So I'm going to say data is symmetric. And if you're writing down a reason for yourself, the reason is because the mean, median, and mode are very similar. Or in the case of the mean and median are exact, right? Okay. The key is that data is symmetric. What's that tell me?
It's the mean and standard deviation.
It's the mean and the standard deviation. Well, what do you got with mean? Okay, mean is 15. Not 15. I heard 15. I'm imagining things, aren't I? Okay. Huh? Okay, don't ask me how I heard 15, but I did. Okay. Mean is 58, yes? Don't ask about whatever I heard, because I don't know. Okay. Standard deviation. How are we doing standard deviation? Excel, unless you've learned how to do it on your calculator, right? Which it is doable on the calculator. I just was not a fan of it. I thought Excel was, I like Excel, I guess, because you can go back and you can check your mistakes. Okay, I feel like if you enter it wrong on the scientifics, you can't really see what you did. I don't know. Maybe I need to play around with it more. So mine would encourage you to try standard deviation right now because it's been a whole 24 hours since I taught it. And maybe you remember from yesterday, maybe you don't. We were all here in this class yesterday, correct? Okay. So you know you need to be on the formula page, right? And then, yep, just start typing your numbers in. You got it. Yep, you're on the formulas. And then those three little dots. Drop down, statistical functions. Statistical functions, you pick standard deviation dot P for population. And then you enter all the numbers. Number, comma, number, comma, number, comma, number. And again, the best way I can say is if you get a wrong answer, go back and check what you typed in because you can tap on that box and you can see what you typed in up above. And that's how I've been able to help people find their mistakes. Okay. I'm assuming I don't need to put this back on the board.
I'm doing the rest again. Just
I have 2 decimal places on my answer key, I think.
I switch around there.
That's fine. I don't. Sometimes I put the whole thing in. I don't honestly know what homework is asking you to do.
I know you had to round.
Yeah, I don't know what homework's asking you to do. So you'll have to watch. I didn't pay attention to that this time. So, yeah, Jonathan was asking, what are we rounding to? I don't have a set of rounding directions right now. You'll have to watch homework and see what they say. It comes up more than this on the iPad, though, right? So I just wrote down 1.87 on mine. Yeah, you have 083. It probably goes on. It's probably not just that. So. I don't really, at this point, I don't really care how you write it down. I'm not going to be picky about that. Are we getting success here? I wanted to give you a moment to practice again, right? Because you're going to have to do this in homework some. Okay. Are you trying the next example without me? Or are you still finishing this example? Now, you guys, if you think about it real quick, I should talk about this standard deviation here. The mean is 58. That standard deviation is really little, isn't it? 1.87. Well, that's really little because what do you notice about all these numbers? There's a lot of them, but they are all very close into proximity to each other, aren't they? I mean, your median's 58, and then the lowest is 55, the highest is 61. They're very, and that's what that standard deviation is indicating is it's like within an average, the numbers are within 1.87 of the median, or mean, I mean. So it's saying that they're very close together. Okay. So let's practice one more time before we move on, and this is B. You can take a guess by looking at the numbers if you want, whether you think it's skewed or symmetric. You can officially check yourself, though, using your mean and median and mode. Anyone have any luck with the mean yet? That's what I have written down. It adds up to be 1,690. You're dividing by 12, I think, right? Yeah. So 140.83, and the 3 appears to be repeating. What about the median? Okay? So 1, 2, 3, 4, 5, 6. I'm going to say you must be telling me when we count in 6 numbers. Isn't that what you said? Oh, okay. So you count in 6 each way, you land between 130 and 140. And what's halfway in between 130 and 140? 135. Add them and divide by 2 if that makes you feel better. What's my mode? 110 because it repeats 3 times, yes? Okay. So, what are your thoughts? $140 and $135 are kind of far apart. Okay. So, I would go with this data is more skewed. And if you look at it, I think there's definitely more numbers here clustered together lower than there are in the upper. Okay. So, if that's the case, if you compare it to the graph up above, there's more numbers clustered lower. That's going to be data that is skewed to the right because the tail is going to be going off to the right. I can also look at the fact that the mean is higher than the median. And if you go back and look at that picture, when the mean is higher than the median, that is a skewed right example. Okay, data is skewed right this time. And I'm saying that because my mean, median, and mode vary. Because my data is skewed, what am I using for the measures of center and spread? That's going to be the median and interquartile range. Well, let's see. Easy one. What do you know about the median? 135. Interquartile range. You have to find it, don't you? I notice I'm finding when I have to. I could have found them earlier, but okay, if my median's here in the middle, remember, you don't use the median, you just use all numbers to the left of the median. So I'm going from the 110 to the 130. 6 numbers, we're to my middle number. In between 110 and 120, which is 115. So my first quartile is going to be 115. What's my third quartile going to be? In between 160 and 170. Should probably be writing these numbers over here. So what's 165? This one was 115. So upper minus lower, 165 minus 115 is 50. Okay. Okay, ready for the next page? The next page takes us with the idea of still trying to decide, is something a normal distribution, so more symmetric, where you got the bulk of the information in the middle, pieces tailing out on the end, or is it skewed one way or the other? Okay, where you have a lot of bigger numbers or a lot of smaller numbers. So we can look at these two ways. You can look at a picture, which we have some pictures on the first view, or you can just kind of think about the scenario and think about how are these numbers going to be represented. So the first one up here, we want to know, are the following variables likely to have a normal distribution? And keep in mind, when we talk normal, you can also think that that was how we talked about symmetric earlier, right? It's a normal distribution, it's symmetric, it's equal halves. So A is the heights of all the people in a large group. So if you have a large group of people, what do you think about their heights? I don't know. Morning class wasn't so sure about this one. What? Okay. And if nothing else, the picture is kind of leading us that way, right? But think about it. If you have a large group of people, you're going to have some shorter people, right? You're going to have some taller people, right? But generally speaking, where are a lot of people going to fit?
Average.
Just kind of average in the middle, right? You walk down, you look out in the hallway during passing period. There's going to be, some shorter people mixed in. There's going to be some really tall people mixed in. But then a lot of times there's just kind of, I feel like it's a sea of bobbing heads out there, right? Like, just, they're all kind of, mixed in together. And so that's, and by looking here at this picture, you can see the normal curve. Okay, so is this likely to have a normal distribution? Yes. And I don't really have a good explanation to write down. Feel free to write an explanation down for yourself. I'm just going to say yes, normally distributed. Okay. B. The probability of landing on each of 8 equal parts of a spinner. So you visualizing a spinner? We take a spinner, we spin it. What's your chances of landing on 1 versus 2 versus 3 versus 4, 5, 6, 7, 8? What?
The chance is always
It's all the same, right? There's an equal probability for 1 as there is for 2, as there is for 3, so on and so forth. So if that's the case, there's an equal chance, do we expect a normal distribution? No. Now, is it all going to happen equally? No. But are your middle numbers going to happen more than the outside numbers? Definitely not. Okay? Now, if you look at this picture, this doesn't fit normal, does it? And it doesn't necessarily fit skewed either. But it's definitely not, it doesn't fit the normal because it's just going to kind of vary. And what this is a frequency chart here. So this is saying the 1 was landed on like 16 times. The 2 happened like 13 times. The 3 happened, 7 times? So even though they all had an equally likely chance of happening, that didn't actually happen. So, is this a normal distribution? No. And I'm trying to remember how I put it down. Each probability has an equal chance of occurring. Okay. If you're struggling with seeing A and B, C should be more obvious, I feel like. When I give you guys an easy test, what do you know about the scores, the results? If it's an easy test, the scores are probably clustered at the top, right? Okay. So if the scores are clustered at the top, is that going to be a normal distribution? No, because a normal distribution has all the scores in the middle. Has them, but this, my average is going to be hold higher. Now, did you look at the picture? Score is not an easy test. If you look at that as a curve, can you see how it is lopsided? Okay, this officially would be called skewed left because my tail goes off to the left side. But that's what happens when I give an easy test. The scores are all up top, and so it's skewed left. So no, and I'm going to say exactly that. The scores are skewed left. What about the number of children in a family? What? Okay, skewed right, because what's most likely to happen? Lesser amounts of children? 0 children, 1 children, 2 children, 3 children, 4 children. How often do you see 10 children? Not often, right? I'm not saying it doesn't happen, but it is less likely, right? I mean, I feel like once your kid has 3 or 4, it's less likely. Okay? So, and again, can you see the shape of the curve here? That's very skewed, isn't it? So, no. And let's see. I'm going to say more families have fewer children. More families have fewer children. This data is going to be skewed right. Okay. You got an idea for how these are working, right? Let's try the bottom 2 that don't have pictures. Is each situation likely to be normally distributed? Weight of individuals in a population. And again, I know it's all a matter of opinion. It's all trying to analyze trends and all that, but thoughts?
I would say yeah. If it's like the height.
Exactly. There's going to be an average in the middle, yes. Is everyone going to meet that average? No. You've got some people that weigh a lot less. You've got people that weigh more, right? It goes both ways. And so weights of individual in a population. Yeah, I would likely say normally distributed. Now again, could we argue that? Oh, I'm sure someone could come up with a way to argue it. But also on the flip side, did they give me any data to go with here? No. They just gave me the problem. There was no picture to go with it. There was nothing. It's just kind of think about the situation. Now, I feel like the next one is a little bit less argumentative. The score is on a difficult test.
Is this a smart class or a normal class?
Regardless, it's a difficult test.
So they're more likely to be skewed to the left.
Okay.
Well,
Right.
yeah, right.
It'd be called skewed right. I know, I'm struggling with this whole left versus right thing. The bulk of the scores would be lower. And if the bulk of the scores are lower, here's what I'm visualizing. I'm visualizing this. Bulk of the score is lower. And if the bulk of the scores are lower, then that puts it as skewed right. Where the tail is how you say it's skewed.
Right.
Trust me, I really struggle with, I want to call this skewed left. That's what my brain, maybe it's just me, but that's what I'm struggling with. So I'm going with how it's taught though. So scores on a difficult test. Normally distributed? No. I'm going to say scores likely skewed right. Okay. Okay, so here's what I'm going to say. We officially have 2 problems left in the notes, yes? Now, there's 2 different sets of information in the book when I created the notes. In all honesty, if you start looking at that back side, it really kind of matches up with what we already did today. When you're trying to, the question earlier was what are the better measures of center and spread? This is kind of what is the type of distribution in center and spread. So it's really end up doing the same thing again. What I think I'm going to do is we may finish, we may finish one or both of these tomorrow. But then I'm going to do that, and then I'm going to give you guys work time. Because I am kind of afraid, I don't know if anyone started the homework yet. I would encourage you to go ahead and possibly start tonight. I'm kind of afraid of how long this homework will take. I think I made it 14 questions, but some of these could be longer. So that's kind of where I'm thinking I might head tomorrow. And I don't think you guys will complain. Okay? So we'll finish the notes one way or another, and then I'll probably plan on some work time. And then we'll go from there. And it pushes off me starting the next lesson until Monday.